NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new. More mysterious, more beautiful than humanity's dream.
For weeks, speculation rippled across the global scientific community following subtle, unexplained data anomalies returned by the James Webb Space Telescope, JWST, during its targeted observations of Proxima Centauri, the closest star to our solar system. The focus of its sensors was Proxima B, a rocky exoplanet situated within the habitable zone of the red dwarf star. What began as routine analysis of its atmospheric composition quickly escalated into one of the most electrifying revelations in human history. Unmistakable indicators of an advanced extraterrestrial civilization. Before we start, hit the like and subscribe buttons for more exclusive news. It started with the detection of atmospheric signatures far too complex and structured to be explained by known geological or biological processes. Spectral lines revealed a precise, repeated pattern of chlorofluorocarbons, CFCs, artificial compounds on Earth associated solely with industrial activity. Unlike Earth, where such emissions were curbed to combat ozone depletion, the density and variation of these chemicals in Proxima B's atmosphere were not just detectable, but patterned in a way that suggested intentional modulation. There was no known natural process that could account for their regularity and abundance. The implications were staggering. Proxima B, a world once thought of as merely a rocky neighbor, might be home to an intelligent species with technological capabilities. As the JWST refined its scans, the data accumulated. Orbiting satellites around Proxima B were observed via intermittent occlusions, small consistent shadows passing in front of the star, timed to what could only be orbital periods. These objects weren't natural moons or debris. Their geometric uniformity and synchronized patterns suggested artificial origin. These were likely satellites, or perhaps components of a larger orbital network. The signals were too exact, their trajectories too aligned. Here was a civilization not only capable of launching space-bound structures, but coordinating them with precision. One of the most startling discoveries came when analyzing infrared emissions. JWST's sensitive instruments picked up localized high-temperature regions on the planet's night side. Not natural hotspots, but clusters of energy emissions in the thermal infrared band. These appeared as concentrated thermal zones, akin to industrial complexes or urban centers seen from Earth's orbit. What differentiated them from geological hotspots was their organization, grid-like patterns, uniform in spacing, static in intensity. Nature seldom works in straight lines and perfect symmetry. These zones pulsed with energy, hinting at sustained activity powered by some artificial energy grid. Proxima B's illumination at night was perhaps the most visually compelling evidence. Faint light glimmered across the planet's dark side, light that matched no natural luminescence. There was no trace of volcanic glow or auroral activity. Instead, the light distribution resembled a planetary infrastructure similar to a cityscape when observed from orbit, scattered across its surface in nodes and networks. These patterns responded to Proxima B's rotation and seasonal shifts. Some lights dimmed while others flared, suggesting a dynamic energy use system, potentially linked to civilization-scale resource management. More intriguing still were the narrow-band radio pulses. Over several observation cycles, JWST's companion instruments, particularly those linked with Earth-based arrays, detected rhythmic, tightly modulated bursts in the radio spectrum. They weren't random nor cosmic background noise. These signals had structure. They repeated with millisecond precision and occupied a frequency band that, on Earth, is typically reserved for deep space communication and satellite telemetry. The pulses had interludes and modulations, patterns akin to encoding systems. Some researchers posited they could represent a form of digital communication, not a broadcast aimed at Earth, but part of the civilization's internal communications infrastructure. Yet even the unintentional leakage of such signals betrayed a level of technological advancement far beyond rudimentary radio. The implications reverberated beyond the astronomical community. Here was the first empirical evidence of intelligent life beyond Earth. Not microbial fossils, not the faint chemical whisper of primitive organisms, but signs of a civilization, technologically capable, managing energy, transmitting information, and possibly terraforming or geoengineering their world. It overturned centuries of speculation and transformed the Fermi paradox from a philosophical question to an empirical one. We were no longer alone in the galaxy. Life, intelligent and industrious, had emerged independently, and not even that far away. The placement of Proxima B as a candidate for advanced life had always been a tantalizing possibility. Located just over 4 light-years from Earth, its proximity made it a prime target for detailed observation. Earlier telescopic campaigns, including data from Hubble and the Atacama Large Millimeter Submillimeter Array, ALMA, hinted at the planet's Earth-like mass and potential for harboring liquid water. But the JWST pushed that frontier farther, offering unparalleled resolution and sensitivity to electromagnetic spectra, capturing details down to the molecular fingerprint of Proxima B's atmosphere. What struck many observers was not just the presence of civilization, but the apparent stability of their technological infrastructure. The spectral signatures of their orbital systems, energy usage, and emissions didn't fluctuate chaotically. They maintained consistency over time, suggesting a civilization not in its infancy, but one that had sustained a technological equilibrium, perhaps even ecological balance, for decades or centuries. That longevity hinted at societal resilience. They had avoided collapse, mitigated their own environmental dangers, or found ways to manage growth and consumption across a planetary scale. This led to deeper speculation about their possible technologies. If their power signatures were any indicator, they might be harnessing planetary-scale energy, perhaps nuclear fusion, zero-point fields, or advanced solar harvesting. Their use of high-frequency communication bursts implied mastery over data compression, possibly even quantum communication methods if entanglement signaling were involved. Their urban or industrial lighting, visible in the infrared and optical spectrum, could be designed to minimize light pollution while maximizing energy efficiency, a sign of environmental awareness. Astrobiologists, philosophers, and sociologists pored over the implications. If intelligent life evolved on Proxima B, what were the convergences and divergences with human civilization? Did they evolve social structures? Were they unified or fractured? Did they practice science, philosophy, or art? The very existence of orbital infrastructure suggested complex coordination, perhaps a planetary government or a highly cooperative culture. Perhaps their cognitive evolution differed entirely, shaped by the red sun that warmed their skies and the tidal locking that shaped their day-night cycles. One compelling question was their perception of the universe. Given their apparent capabilities, they almost certainly knew of Earth's existence. Our planet reflects a distinctive spectral signature in space, an oxygen-rich atmosphere, chlorophyll reflectance in the near-infrared, and narrowband radio emissions. For over a century, Earth has been leaking signals into space. Television broadcasts, radar pings, satellite uplinks. To a civilization as advanced as the one detected on Proxima B, these signals would have arrived decades ago. It raised the tantalizing possibility that they had been observing us all along, silently watching from the shadows of interstellar distance. This shifted the paradigm of contact from hypothetical outreach to one of mutual observation. If they were aware of Earth, why hadn't they initiated contact? Was it a matter of ethics? A self-imposed non-interference directive? Did they classify us as too primitive to engage? Or did they fear us, given our volatile history and still nascent command of technology? Perhaps they simply did not see communication as necessary, or even possible, across such different evolutionary and cultural chasms. Another pressing consideration arose. What else had the JWS seen but not yet revealed? If such a civilization existed on Proxima B, a relatively nearby, unassuming rocky planet, how many more dotted the stars? Had we stumbled upon an outlier, or was this the first drop in a flood of discoveries to come? The universe suddenly no longer felt vast and empty but teeming with potential. Proxima B had become a mirror, a reflection of what humanity might one day become, or a warning of what we might never reach. For Earth, the detection demanded a re-evaluation of priorities. Funding for space exploration surged as governments and private companies recognized the new stakes. Interstellar travel, long relegated to the realm of science fiction, took on fresh urgency. Theoretical propulsion methods, from light sails to antimatter drives, returned to the drawing boards, this time with a goal: reaching Proxima B, Not just with telescopes, but with machines, perhaps even ambassadors. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on James Webb finding life on Proxima B? Will contact happen? We want to hear from you. Thank you for watching, and see you next time.